Hello and welcome to this video on chemistry, which is the first in the series. In this video we'll be introducing the concept of moles. Moles are a way of measuring the number of atoms or molecules of a substance in a beaker, cup or dish. There are a huge amount of atoms of a substance in an everyday amount of substance, like in 10 mils of water. So instead of writing the actual number of atoms, we divide this actual number of atoms by a constant called Avogadro's number and call this new number the amount of moles of a substance. This amount is usually a smaller number that can be worked with, like 0.01 moles or 100 moles, and not a big number like 6 followed by 23 zeros. Avogadro's number was calculated to be equal to a large number that would make the number of atoms or molecules of a substance in the order of 100 to 0.01, and so much easier to work with. Its units are mole and its symbol is N, the small n. As an example of using moles instead of the number of atoms, here's a question asking you to find the number of moles of carbon atoms in this beaker after being given the number of atoms. And there are a lot of atoms, about 2 followed by 24 zeros. I know this picture isn't realistic because the actual carbon atoms would be millions of times smaller than the ones displayed here. But I hope that you get the idea. There are a large number of carbon atoms in the beaker, and this number can be expressed as an amount in moles. To work out the number of moles, we firstly use the moles to molecules equation. It uses Avogadro's number, which is extremely large. We then manipulate this equation to make N, the amount of moles, the subject of the equation. Then we substitute these numbers in, which are both incredibly large numbers. And I hope that you're used to reading numbers in JavaScript notation. Then we get this answer, being a much smaller and rounder number. Notice that the answer isn't just 3, but 3 to 4 significant figures. Another example is given here to work out the number of atoms of a given amount of substance from the amount of moles of it. We firstly use this equation like we used it before, and the variable we want is already the subject, so there's no need to manipulate it. Then we substitute all the numbers in, and so we arrive at this number giving the number of atoms in the beaker. Atoms are usually bonded together into groups of 2 or more to make molecules. An example of this is the hydrogen gas molecule, which is made up of 2 hydrogen atoms bonded together with a covalent bond. In this example, an amount of hydrogen molecules is given, and the amount of corresponding hydrogen atoms must be calculated. In order to answer this question, it must be stated that there are 2 hydrogen atoms for every hydrogen molecule. We express this as an equation, the N standing for the amount of atoms or molecules in moles. We then substitute in all the values that are known. We get the answer in moles to 4 significant figures. There are twice as many hydrogen atoms as hydrogen molecules. In salts, the atoms are bonded together using the ionic bond, where the atoms of one type of atom, usually the metal, donate an electron from its outer shell to the non-metal, so that they both have completed outer electron shells. This causes these atoms to be electrically charged, so they are held together by electrical attraction. This is called the ionic bond. The atoms usually bond themselves into large chunks of matter called crystals, but the molecule or unit is said to be the minimum ratio of the 2 atoms, like for example in common table salt called sodium chloride. The ratios of these atoms are 1 to 1, So the molecule of salt contains one sodium and one chlorine atom, even though they've been bonded together in a huge crystal containing millions of these atoms all bonded together into what looks like one huge molecule. Here in this example we have to find the number of atoms expressed as a value in moles in this beaker, given that there are 31 moles of salt. Well, the molecule of this salt contains 2 atoms, since this is the simplest ratio between the 2 different sorts of atoms. We can express this as an equation. The moles of atoms is equal to twice the number of sodium chloride molecules. We can then plug the values in. So then we find the number of moles of atoms expressed in moles. Here in this next example we have another type of salt, lithium nitride, and the simplest way of expressing the ratio of these atoms to each other gives us this molecule Li3N. So we know that there are 3 times as many lithium atoms as lithium nitride molecules. We can express this as a mathematical equation. We then plug in the values and then solve, giving us the number of lithium atoms in moles. Metal atoms are held together using the metallic bond, which is where all the outer electrons run loose as a sort of plasma around the positively charged metal ions. It is a very strong bond for atoms like iron. A molecule of a metal is said to be a single metal atom, even though they clump together in their millions to form large nuggets. Here in this example we have to determine the number of iron atoms in this container when we are given the amount of moles of iron in it. The number of atoms of any metal is equal to the amount of it in moles. We can write this down as a mathematical expression, then easily solve it. So I hope that this video has been helpful for you in studying chemistry, and the first part of chemistry, moles.